Hello, welcome to ANS Solver. This is the third question of the paper. So the times and minutes taken by competitors to complete a puzzle, has a mean of u and a standard deviation of 3. So now the times taken by a random sample of 10 competitors, is given. So we need to state a necessary assumption and calculate a 97% confidence interval for the mean. So the assumption is first, we assume that the population distribution is normal. That's because nowhere they have mentioned, so we need to assume that. Now what we'll do is we need the mean, so we'll calculate the mean. The mean is basically the summation of x over n. That means it's the summation of 25.2 plus 26.8 plus 18.5 plus 25.5 plus 30.1 plus 28.9 plus 27 plus 26.1 plus 26 plus 24.9 over n, which is a number of values, which is 10. So when I solve this, I get my answer as 25.9. Got it? So now what we need to do is we need to calculate a 97% confidence interval. So I can basically write this as, we need something here, and 97% basically means 0.97. Agreed? So if this is 0.97, 1 minus 0.97 is basically 0.03, which will be divided by 2. So I'll simply get 0.015, and 0.015. Agreed? Now what I simply do is, if you see, I have my population as my z upper equals to x upper minus the mean over the standard deviation over root n. I need to calculate the x upper. X upper basically means we need to do 0.97 plus 0.015. So 0.97 plus 0.015, which I know is 0.985. So what I can do is I can go on the up on the table and I can calculate 0.985. So if you see 0.985, it's nowhere in the critical values. So 0.985 is somewhere here. So I get 2.17 if you see. Was 2.1 here and 7 here. So I can write this as 2.17 and minus 2.17. So I can write this as 2.17 equals to the x upper minus the mean which we calculated, which is 25.9, over the standard deviation, which I know is 3, over root n, which is root 10. So I can simply solve this on my Calc. Agreed? So when I solve this on my Calc, just give me 1 second. Solving it. When I solve this on my Calc, I get my answer as 27.958. And here I need the z low value, which is equal to the x low minus the mean over the standard deviation over root n. I can write this as minus 2.17 equals to, because I know they are symmetrical, so x lower minus 25.9 over 3 over root 10. So I can write this as minus 2.17 into 3 by root 10, which is plus 25.9. So I can write this as 23, the x lower, 23.84. So I can write this as 23.8, 27.95. Correct? This is what we do. We write lower limit comma the upper limit. So now two more random samples. Okay, they are taking two samples now. Okay, are taken. Their times are used to calculate two more 97% confidence interval. Find the probability that neither of these intervals contain the true value of mean. Now only take one sample. One sample will have a normal distribution curve something like this, with 0.97 being here, and here I get this and this, which basically add up to 0.93 obviously, because 1 minus 0.97 is 0.03. But now this is the area of rejection because this lies here. This is the area where the mean does not lie, but this is only for one sample. So you basically do 0.03 into 0.03. So when you do that on your calc, you get your answer basically as 0.0009, which is basically the final answer of the question.